Why water boils at 100 degrees and methane at minus 161. Why blood is red and grass is green. Why diamond is hard and wax soft. Why glaciers flow and iron gets hard when you hammer it. The answers to all these problems have come from structural analysis. That's how the Nobel Prize winner Max Perutz summed up X-ray crystallography. Never heard of it? Don't worry, not many people have. Yet it's arguably one of the greatest innovations of the 20th century. 28 Nobel Prizes have been awarded to projects related to crystallography, and the very first of those is where it all began. It's now 100 years since, following early work by Max von Laue, the first structures were determined by father and son team William and Lawrence Bragg. In 1913, they fired a narrow beam of X-rays at a humble salt crystal and photographed the diffraction pattern as the crystals split the beam into many rays. Lawrence soon realized that this pattern held the clues to the atomic structure of the crystal itself. The equation he developed, Bragg's law, made it possible to work out how the spots in the diffraction pattern are related to the specific arrangement of atoms in the crystal. 2 years on, and the Braggs were awarded the Nobel Prize. Impressive stuff. Not only that, the Braggs mentored a dream team of crystallographers who went on to work out the structures of a huge range of molecules. From Kathleen Lonsdale, J.D. Bernal and Dorothy Hodgkin to David Phillips, John Kendrew and Max Perutz. Remember him? Plus, Rosalind Franklin and others even helped map the structure of DNA, probably the most famous result of X-ray crystallography. Today, the work hasn't stopped. Crystallography remains the foremost technique for working out the atomic structures of almost anything, which is very useful for finding out why things behave the way they do. From the metallic structure of the blades of a jet turbine to the immune system fighting off viruses. Turns out, Max was right. Modern crystallographers are doing exactly the same thing as the Braggs, just at a larger scale with more sophisticated mathematical methods and more impressive machines. Crystallography is even reaching beyond our planet. The Curiosity rover is now performing X-ray diffraction analysis of the soil on Mars. But there's plenty of unfinished business back on Earth. There are still many thousands of complex molecules to look at, and a lot more questions to answer.